Hello, in this class of GSM, we will study about SS7, which is Signaling System Number 7 Architecture. So, in this class, we will be studying about architecture of a system, which is Signaling System Number 7 Architecture. Now, the architectures, like we have various units in this. Now, this one is connected to SCP. Now, SCP is connected to SSP or SCP. Now, the architecture as the node entities connected are so this one STP, which is known as signaling transfer, which is signaling transfer point. So STP as signaling transfer point, SSP as signaling switching point, and SCP as this one as signaling control point. So basically the main entity here in this part is SCP, STP and SSP, where SSP as a signaling switching point, SCP as a signaling control point and STP as a signaling transfer point. So like I will name the link through which it is connected, then we will discuss about their description of the various links. So like A, so A link, then B link. And after that B link, we have a C link. So this one is named as C link. So again, this one is the same as E. So we require another one link as this one as E link and this one as D link. So we have link from A, B, C, D, E. And each and every link has its own description and a name. So this is the architecture of SS7 in which we require various transfer points connected to one another through a defined link as B, D and C link. After that, these STPs are required to connect to SSPs or SCP by a link. So this one has a link. And after that, if two SCPs or SSPs are connected, that also require a particular connection or a link. So first of all, let's understand that what is a link. Now, link is the interconnection between various points of the network. As it is a transfer point, it is also a transfer point. Then we have a control point. That means the link which is connected to points of a network is known as SL, where SL as a signaling link. So SL stands for signaling link. And this signaling link is basically the interconnection between different signaling points. Each and every entity, whether SCP or SSP or even STP, that will represent a signaling point. So I have various signaling points arranged or combined to one another. So the connection between two points is known as a signaling link. Now this signaling link is a digital transmission channel. So this signaling link is basically a digital transmission channel, and this digital transmission channel is of 64 kbps. So that means each and every signaling link A, B, C, D, E is of 64 kbps. Now we have, that means if we require more rate, so we require to multiplex together so that we can have rates of so we have multiplex together, so we can have rate of 1.4544, 2.048, then we have 8.448 Mbps. So whatever the more data rate we require to multiplex the various signaling links together of 64, which is the standard of digital transmission. So this is about a signaling link. Now let's move to the next point, that what is a signaling point? So let's understand the basic unit, which is a signaling point in a network architecture. Now, each and every signaling point in a SS7 network is identified by its numeric point code. So, like I have STP as a signaling point, we have SCP, where we have number of SSP. So, each and every, as this one as my signaling point, so each and every is identified by its NPC, where NPC stands for numeric point code. So for each and every signaling point, we require a point code for an entity, and that is a numeric point code. Now, numeric point codes are carried in by signaling messages. That means who carries these codes? These are carried by signaling messages. So these signaling messages will have NPCs in between so that they can travel from source to destination. One from STP to SCP. So there is an exchange of signaling messages between source and the destination, and because each and every unit is represented by its point code, and those are being carried by signaling messages. So that means signaling messages have their own identifications, and that identification is numeric point code, and whenever there is a transfer of packets or from source to the destination, there is the exchange of that codes in the form of signaling messages. Now we have various types of signaling points as we have discussed here, like we have STP, SCP or SSP. Now this STP as signaling transfer point, this one as signaling control point, SSP as signaling switching point. So these are the various points. Now let's start with the very first, which is SSP. And this SSP stands for signaling switching point. So what is signaling switching point? Now this signaling switching, as the name as a switching, so that means it performs the functions of switching. So it is local exchange to the subscriber. So I will write that it is local exchange to subscriber. So whatever my local exchange, is to the subscriber is my signaling switching point, or I can say that it is an interface to telephone network. As exchange provide functions of the switching, so that's why it is named as signaling switching point. Now what is the function of this? It converts my voice signaling to SS7 signaling link. So it converts voice signaling to SS7 signaling links or the various messages. That means it performs the conversion of the signaling messages so that it can be forwarded to the various databases. Now next one, after SSP, which is the switching point, which act as a local exchange and perform the function of the switching. Now next we have STP as a signaling transfer point. Now what is the function of the signaling transfer point? It is basically a network node. So this one will form as a network node and it works like a router. It works like router. That means the functions are similar to that of a router to perform routing of messages. Routing of messages between different signaling points. So as I have various signaling points connected, so it will work as a router to form or to pass messages. That's we have more number of STPs in a network because STP will function similar to that of a router so that it can forward messages to different signaling points of a network. Now we have next one as SCP. SCP as a signaling control point. Now it provides an interface with various databases. So if I have like HLR is one database, so SCP as a signal control point will perform or will form an interface with databases so that we can process all the queries and subscriber information. So it will handle all the database queries, all the databases queries, as well as it will handle all the subscriber related information. So this is the function of signaling control point. Now that we have discussed. Now in a complete SS7 architecture, we have entity as a switching, SCP, SSP, then we have signaling control, and after that we have various STPs. Now we have discussed the function of each and every unit in that complete SS7 network. Now comes the link. So now we will discuss signaling link types. So we have a topic as signaling link types. Now we have discussed about like we have A link, then B, then C, and then D, soon up to E. And we also have a F link. Now each and every link has its meaning, like A, which is known as access link. Then for B link, so this B link is bridge link. Now the link as C, So this one has my cross link. After that D will form a diagonal link. E as for extended link. And F as fully associated. So these are the types of the link. Like we have in the diagram, we have discussed like A link, B link, C link, and we have formed the various links together. Now comes like what is the function or why we have different link. Now whenever we have connectivity from SCP or SSP with STP, we have access link. Like in the diagram, like we have SSP or SCP. Now I have connected to two different STPs. So this link will be a link and access link because the subscriber has to be subscriber information or various switching information has to be retrieved by STPs. So that will form a link. So that's why it is known as access link. Now comes the B link. So B link is between two different STPs. So if I require to connect two different STPs like this, so this will form a B link. And B link is similar to that of a diagonal link. That means if STPs are diagonally connected to one another, so that will represented as a diagonal link. So I will form that this will also link between two different STPs. So this one has a D link, bridge and a diagonal. Now we have a cross link. So now cross link is required. This is also between two STPs. We have represented with this signal. Now this cross link is used in case of STP route failure. So in case of any failure of the network, we have provided another path, and that is in the case of a route failure, we have provided a link which is known as cross link. Now for extended, now this is required extended whenever we require to connect one SSP to alternate STP. That means a different STP, we require a connectivity with different STPs. So we require extended link. That's why named as extended. Now fully associated between two different SCPs, SCP to different SCP. So we require it is as a fully associated link. So these are the various links in the architecture. Now in a complete architecture, we have drawn the various signaling points. Now we have discussed the signaling points. Now after that, the various links between them. Now comes the next some entities in the SS7 which is required. Like we have SLS. This SLS as signaling link set. Now it is a set of, that means a set of various signaling links as B, C, D. So that will form a complete set of the various links together. That's why it is named as a signaling link set. For example, I require to have signaling connection from one SP, then STP, then I require to go to another STP, then SCP. So what are the link I am following will be my complete set of the links, and that will be represented as a signaling link set. Now this is one term which is used in this architecture. Now another description as SR and also SRS. This SR, which is signaling route. And SRS is signaling route set. The route followed like from 1 to 2 to 3. So this will form my complete route and a set of route to be followed by signaling messages as a signaling route set which is used. Now each and every link that we have studied A, B, C, D, E, F, each and every signaling link has a code so that we can differentiate it. So that is represented as SLC, where SLC stands for signaling link code. That means the code given to a particular link of SS7 which is known as signaling link code. Other than this, we have CIC, which is circuit identification code. Now, identification digit given to a particular circuit has its own CIC. That means CIC is the code which is given to a particular circuit and that is represented as CIC, circuit identification code. Now these are the various entities and the terms which is used in the SS7 architecture that we have discussed today with its nodes and the various links together. This is all for today. We will continue with SS7 in our next class. Thank you so much.